Absolute value inequalities. This is a part of algebra. First, we will work on inequalities of the form the absolute value of ax plus b is less than c, and the absolute value of ax plus b is less than or equal to c. It doesn't matter which one we go through. The other case would just include or not include the equality symbol, as the case may be. I've chosen to go through the case with the equality symbol, but if you replace this with just a negative, it would also serve as a good example. The solutions to absolute value ax plus b is less than c can be found by the two inequalities a plus b greater than or equal to negative c and a plus b less than or equal to c. A lot of students want to know, why does this inequality change direction? Memorization can get a little cumbersome as we go through more and more math, so it's best to go back to the basics and understand. But while we're here, let's address this word and. We're going to get two inequalities. We want solutions that are in both. So we use the word and. You can think about the idea that we started with a less than symbol or less than or equal symbol means we want things in between the solutions of the two branches. The word and is part of the solution. So we get two branches and we want only what's between the two endpoints of those branches. Now we're going to take an example with actual numbers. Solve the absolute value of 3x plus 2 is less than or equal to 4. To understand why the direction of the inequality symbol changes, we get basic. Start with the branches negative 3x plus 2 is less than or equal to 4, and 3x plus 2 is less than or equal to 4. When I have my students go through this, I always go back a step. Yeah, it does add an extra step, but we add the understanding. Memorizing that flipped sign, it just begs to cause problems. We go over this also in my absolute value equation video. So, what really can be positive or negative is what's inside the absolute value bars. So I get negative 3x plus 2 is less than or equal to 4. And I'll go down the left side to solve that branch. Here's the word and. 3x plus 2 less than or equal to 4. And I'll go down the right side to solve that branch. First, right here, I multiply by a negative 1 to take that negative sign out. And hence, the inequality flips. So I go to 3x plus 2 greater than or equal to negative 4, 3x greater than or equal to negative 6, or x is greater than or equal to negative 2. On the other side, I don't have a negative to deal with, so I go through 3x is less than or equal to 2, subtracting 2 from each side. X is less than or equal to 2/3. So my solution is x is greater than or equal to negative 2 and x is less than or equal to 2/3. Or all the numbers from negative 2 to 2/3 inclusive. Now we'll look at solutions to the absolute value of ax plus b greater than or equal to c. And there'll be the same mechanics as if I didn't have the equality symbol. And they are found by solving the two inequalities, ax plus b less than or equal c, or ax plus b greater than or equal c. Now we use the word or. We're going to end up with very small values as x tends to negative infinity, and very large values as x tends to positive infinity. The greater than symbol, we only need one of those branches to be true for the inequality to work. So the word or indicates a solution for either branch is a solution to the inequality. That's a little different. So again, I'm going to solve my inequality 3x plus 2 greater than or equal 4 by taking negative 3x plus 2 greater than or equal 4 in one branch and 3x plus 2 greater than or equal 4 in the other. Going down the left side again, we'll multiply by negative 1 and flip that inequality. 3x plus 2 is less than or equal negative 4. 3x is less than or equal negative 6, or x is less than or equal negative 2. Going down the other side, 3x plus is greater than or equal 4 minus 2, or 2. X is greater than or equal 2/3. The special cases. The absolute value of ax plus b less than or equal c, when c is a negative number, or ax plus b less than 0, which is the negative numbers and 0, has no solution, since any value substituted for the variable will cause a false statement. We can't have an absolute value equal to or less than a negative number, or less than 0 would be equal to a negative number. On the other hand, the absolute value of ax plus b greater than equal c, a negative value, or absolute value of ax plus b greater than 0, as all real numbers as solutions, since any value substituted for a variable will cause a true statement. Actually, if I have anything greater than 0, it would always have to be true.